Well, good morning. Good morning, everyone. So, how are you guys? So, in the last class, I think we discussed about the motion of a particle or motion of an object. Maybe a person is moving horizontally, and the interest was like, how does the time taken? How do you relate the time taken with the distance traveled by a person? Let me just show you the video. Where did I use it? It's here. Yeah. So this was uploaded yesterday. Okay, so this is what it is, wherein you have a person over here, and then you started to made it to move. So what you do is you fix the velocity of the person to be around 0.5 meters per second, and then you change the position of the object. That is, the interest was that. Okay, and then what did we do? We ran this, and as a result of this, you observe that the person was started to move, and as he started to move, we just forward this. Right, as he started to move, you counted what is the total distance taken versus what is the total time, and this is what we did, and I'd also shown you about uh, the various readings, how to take the readings. Let me go back. Stop the video for a moment. And today what we will do is we will conduct the same experiment, but we'll do it in the vertical direction, not in the horizontal direction. Right? Okay. Let me go back and show you what we have done. So this is what we did. Related the distance traveled by a person with the time taken by him. And that's what we did. And we got a average value of a time. We took the displacement. And then I told you how to get the process data. And thereby you calculated the velocity. Velocity was 1 and the same. Now we'll change a little bit, okay, about this experiment. And what we do is, let us first write down the aim. The aim here is to relate the vertical distance. Vertical distance, okay, we can say vertical distance traveled by an object with respect to time. Okay, this is what we are going to do. When an object is thrown. When an object is thrown upwards. This is what we are going to do. Which means what? You are having a ground over here, and from here you are throwing the object. As a result of it, do you expect that as the time proceeds, will it go further at a time t equal to 0.5 seconds or 2 seconds? It goes until here. 4 seconds it goes here. 6 seconds it goes here. Do we find anything like this? Or what do we find? Now, towards it, let us directly switch over to the experiment. Okay. Stop here. Where is the experimental detail? Where is my lab page? Lab page is missing. Maybe I have to go here, and then I have to. Oh, I missed the lab page. Okay, just a moment. Wait, let me open the lab page. So once again, I am going to ophysics.com. And here I'm going to kinematics, and I'm clicking on uniform acceleration in one motion, one dimension. Will this be sufficient? Let us find out. I'm not sure whether this will give you. No, this won't give you. Okay. Let me try it out with exploring projectile motion concepts. Maybe projectile motion. Let me try with projectile motion. Yes, this would be helpful. Now what I'm going to do is, this is the surface of the earth. I'm going to throw it upwards. Okay, shown here are some diagrams. Don't worry about it. So what we do is, here it says that you are going to launch the object from here. See, for example, by default condition, if I click on the fire here, see, the object is going like this. So why is it going like this? Because, okay, you are firing it, you are throwing an object like this. right? So you are making an angle 45 degrees. I don't want to make an angle 45 degrees when I throw vertically upwards. So what should I do to throw it vertically upwards? See, this is 45. I should make this equal to 90. Now let me make it 90. You make it 90. Right? Now you will be throwing the particle here like this. And then the initial displacement of the particle is 0. That means the particle is kept here. Then the initial velocity is 25 meters per second. We have kept this. Now let us fire it. Now what did we do there? We kept the velocity constant. And then as the distance varied, we found out what was the time. Let us fire it. Goes up, then completely goes down. Can you reason why does this happen? The reason is, if you have guessed rightly, the reason is because you throw any object upwards, it should come down. Why? Gravity, right? You reasoned it correctly. The reason here is that gravity pulls every object. As a result of this, the object tries to come down. Okay. So therefore, our conventional experiment of reasoning like how does the distance vary with time may not be helpful here. You may not get so much readings. So we need to change something here. So why I showed you is because when you design an experiment, okay, and when an experiment is already given or already known to you, and you want to modify something, that doesn't mean by just changing the direction, you will get one more. Now you should learn how to modify things. Okay, this is what is the main aim of this experiment. Though this is not an experiment, this is not a procedure which we use. Usually I find students who say, this experiment has been done. Can I change the color of this? Can I change the mass of this ball? This is what they say. Okay, so now what we need to do is we need to think realistically, because when we talk about research is all about going from known to unknowns. Okay, never attempt anything which is going from unknown to knowns. When we say about find a project for your term exam, or maybe for your submission, for your internal assessment, or something like this, students, what they do is they look at some videos and then they say, maybe I can do this. But they look at the complexity of the experiment that he has done. Even a PhD student cannot do it. It will be so complex. But unfortunately, students do not think in this manner. So what we need to do is we need to look at what is known initially, and then we need to go for, okay, how the experiment can be tweaked so that I can conduct a new experiment, or I can use it as a new experiment. That's what I'm going to do here. So your conventional way of thinking as distance varies with time will not be so helpful with the current interface. Of course, you can do it, but it may not be so helpful. Okay. So now what we do is, now let us start with something like this. Now let me fire it once again. See, the particle moves very faster. Okay, you are not able to figure out where is the exact maximum point, where is the minimum point. Nothing you are able to figure, right? So what we do is, so there's a slider here which gives you the animation speed. Slide this to 0. Now once again fire. Now what do you observe? You observe that the particle is moving slower and slower. Now somewhere you are able to get the value. Now, okay, before you start an experiment using simulation, the first thing is explore all the controls. Okay, without understanding the controls, don't start any experiment. Very, very important. Okay, now what we do is, let me reset this. Now, what are the controls here? Initial velocity 25 meters per second, which means the velocity which you give here. Acceleration due to gravity. What is acceleration due to gravity? It is the force per unit mass which the earth attracts every object towards it, right? Launch angle. So this seems to be a constant. I'm not going to change this because in earth, this is 9.8 only. Launch angle is 90 degrees. Okay, so that is also constant. Then y0 is equal to 0, which means what? This is the origin from which I'm going to launch. If I say y0 equal to 10, what will happen? The particle will be raised here, and from there it will be thrown upwards. Okay, it could be a new experiment, which I'm not doing it now. Then next, let us look at the sliders below here. So there's a slider which tells you from t equal to 0 to whatever infinity value. This we are not going to change. Then Vx equal to 0. What do you mean by Vx equal to 0? Which means that I'm not throwing the particle like this. I'm just throwing the particle vertically upwards. Okay. So only Vy velocity exists, which is Vy is equal to 25 meter per second. And then V is equal to 25 meter per second, which is nothing but the resultant velocity. Okay. X equal to 0, the position of the particle. Y equal to 0, position of the particle, the y coordinate is 0. T equal to 0. At t equal to 0, this is what it is. And I have reduced the animation speed so that I am able to see it. Now, if I want to find the position of a particle at any instant, either I can locate it from the slider here, or I can look at the values here. Both are one and same. Then there is a arrow here, vector length. Do I need this arrow or not? If I want to reduce this, the arrow becomes like this. If I want to increase it, the arrow becomes like this. Now, is an arrow useful or is it not useful? That we need to look at. Let me put it to 0 initially and click on file. Now, how does the arrow make a difference? Does the arrow make a difference for recording the readings? No. Say I am looking here. I am looking at this point. Now, the maximum value I observe 27, 28, 29, 30, 31, 31.89, 31.89 was my maximum value that I observed, right? What was our interest? To find out the relationship connecting distance versus time. That's what our interest was, right? Okay. So therefore, so this arrow will not be very helpful. It will be masking our experiment. So therefore, I remove this also, right? Now, most of them, I have made it 0, or which is not useful, I have thrown it out also. Now, let us begin the experiment. Now, once again, let me go to my PPT back. What was the aim? The aim was to relate the vertical distance traveled by an object with respect to time when an object is thrown upwards. Okay. Now, what do? I take an object here. I throw it from here. The object goes to certain height. And you are going to find out what is the distance here. What is the height reached by the object in a given unit of time. And then what happens? The object again falls down. Now, while doing this, we have fixed V is equal to 25 meter per second. That's what we have done. Let me go back to the interface once again to see what best can be said. Because if I ask you, what is my independent and what is my dependent variable? Okay, let me do it from here itself. What is my independent variable? What is your answer? What is your answer here? Independent variable. Independent variable is something which you can vary on your will, right? Now see, usually in the previous case, we had taken the distance as my independent variable. But here you cannot take the distance because let me go back to this. Let me go back to this. Now you see, if I reset this, now everything held constant. Can I vary the distance here? I will never be able to vary the distance because when I fire, let me increase the animation speed. Okay. Now you see, it goes until such height and then once again come back. If I fire it once again, so it goes to the same height, comes back. Fire it thrice, goes to the same height, comes back. Which means I will not be able to vary the height at all. Right? So height will not be your independent variable. What about dependent variable? There the dependent variable was time. Are we able to find time? The first is time can be determined. Okay. So when I click on this fire, see, I can determine it. But I need to fix this one, right? I'm not able to fix it. Every time I do it, okay, it does the same thing. It's repeating. So therefore, independent variable cannot be the height. Now, what else can we show? See, now we are changing the experiment here. Okay, our idea initially was something else. Now we find that finding out the distance versus time relationship is not so easy as we had thought. So somewhere we need to change it. Okay, let us do that. Because we are throwing the particle upwards. Now what we do is, now all these are held constant. What can be changed? We can change the initial velocity. Let us change this. Because without changing the angle, let us change this angle, the initial velocity. Let me put it 10. Now what do you expect? When I put it as 25, you expected or you got the result as something like 31.92. Now, when I fire it and you are giving a lesser initial velocity, what do you expect? Will it go to more than 31.92, less than 31.92, or what can happen? You're right that it won't be going to 31.92. Why? What is the reason? The reason is because you are giving a lesser velocity. When I give a lesser velocity, which means I'm giving lesser energy. What energy? Kinetic energy. If you have an object in hand and you want to make it go upwards, will it go upwards just like that? It won't go. Why? Because its energy is zero. It doesn't have so much energy, okay, in order to escape from the surface of the earth, right? You need to provide an energy. How do you provide an energy? You give a pat on it, right? You give a pat on it. So as a result of it, the object goes upwards, right? It goes upwards, and the more forcefully you pat on it, that means you are giving it more energy, right? And as a result of it, the object goes much larger distance. The lesser energy you give, say for example, if I give like this, then the object only goes to this much extent and comes back, right? So therefore, you should give a more energy, which means now what could be your independent variable? Let me repeat it once again. Let me go back to my PPT and explain it through a drawing. So you have an object which is at this point. If you give a velocity, let us say for example, which is 1 meter per second, the object can go only until this height. If you give a velocity of 10 meters per second, the object can go to a height of this much, right? This could be, let us say 8 centimeters. This could be 8 centimeters, right? So this could be 1 centimeter, for example. If I give a velocity of something like 100 meters per second, then what can happen? This can keep on going to a certain height and once again return back, right? Now, can you tell me which one could be your independent variable? Which one can be a dependent? An independent variable is one which is in your hand and you are able to vary it at your own will, okay? Which is not dependent on anything. That is what you call as an independent variable. Now, what is a dependent variable? A dependent variable is one wherein it depends upon the independent variable. Now, if you have a confusion on understanding independent and dependent, first identify the dependent, which is easy to understand. Now, dependency, this 8 centimeter, this 1 centimeter, which is all dependent on the velocity, right? So therefore, your dependent variable is seen to be the height of the object. Height of the object. Of course, you can take one more variable as dependent also. Can you guess which one is this? Okay, now I will not reveal it. Okay, at the end of the experiment, I will reveal what could be the other independent, what would be other dependent variable. What is my independent variable? Independent variable is nothing but velocity. Velocity. Then we have got dependent variable, independent variable. What is my control variable? Control variable is, what is the control variable? Angle of throw. Angle of throw, which is 90 degrees. Now, what is dependent variable? Height of the object. And how are you going to vary? We do not know. It depends on it. What about independent velocity? Independent variable, which is velocity. How are you going to vary? You are going to vary in terms of 10 meters per second, and you are going to vary in terms of steps of 10 until 100 meters per second. Right? So, what is the unit? Meter per second. Now you see, we have identified what are our variables, and then you can describe how are you going to do the experiment, which I'm not doing it here. And then control variable also you have identified. And then G, the acceleration due to gravity. You're conducting the experiment on Earth, so it is 9.8 meters per second square. Done. Now let us rewrite the hypothesis once again. What is your hypothesis? To what extent does the height of an object vary with the velocity thrown? Right? We already got the hypothesis also. Let us move on to the next one. Now, what's the next step? Conduct the experiment. Simple. Now, let us conduct the experiment. Now to conduct the experiment, what you should do? Now I will remove this show velocity vector, velocity components. I'll remove all this. Okay, let me fire it once again and see whether I get it correctly. Yes, I get it. Reduce the animation speed to 0. Right? We have done everything. Then now we have put it across correctly, all these values. What's the next step? Reset this and we have to start. Now we need to write a tabular column. Right? Let us start the tabular column. So how should a tabular column look like? This is my tabular column. SL number. First is independent variable. What is your independent variable? Velocity. Vy. Y stands for the y-axis. Throwing it upwards in meter per second. Then what's your dependent variable? Height. And then what are you going to do? In centimeters. And then you have trial 1, H1, H2, H3. So almost it's one of the same. Okay. SL number 1. 10 meter per second. Now once again, infographic, what do you need to write? We are going to write in order to determine the dependence of height on velocity. The experiment was conducted as described in the procedure and the readings are being tabulated as shown. This should come the first one. Then what do you have? You should have the legend. What is the legend? Table 1. Lastly, what is it you should have? From the table, what have you inferred? Right? Now let us start the experiment to look at it. Now velocity is 10 meter per second, height. Let us start. Height. Now what we do is, let me change this to 10 and fire it. See, I may not be able to figure out exactly here. It's better that I figure it out at this point. Y equal to 0. Okay. Now let us start this. I don't know whether my screen is shared or not. No, my screen is not shared. Okay. Yes. Now let us begin with. Now towards it, now you see I made this as 0, 9.8. This is 10 over here. I'm going to change this one here and I'm going to note it down from here. Y equal to 0 initially. This value will change. Okay, we are going to do 3 trials. Fire. Right? And what is that? We are going to record the maximum height. What do you mean by maximum height? The particle starts from here, goes to a maximum height somewhere here, and then again comes down. Amongst this, the readings should be changing, and your interest is to find what is the maximum value. Now let us start with this. Fire. 5.1. I have identified the value as 5.1. Okay. First trial was 5.1. Second trial, once again. 5.1. I have identified correctly. Yeah. What I should do is, this is an ideal way of doing it. Most of the students, what they do is, they would have not adjusted this. They would have kept it by default value here. Okay. Now let us redo it. Fire. Why is it going in the negative sense? Oh my God, it's going in the negative way. What did we do? Reset it. Everything is fine. Everything is fine. Yeah. Now let us start. Fire. I am not able to locate it at all. See? 5.83. Okay. I'm not able to get it. Let me reduce this animation speed. I think this would be fine. Yeah. Let me put it across. Oh, I missed it. 3, 4, 5.1. Yeah, 5.1. Second time. 5.1, third time. Five point one. Okay, so now let us write it down there. So you have, so we have made the table. So 5.1, 5.1, 5.1. Second one, 20. Let us go back to this. Let me stop and make this as 20. Where should I make 20? I should make this as 20. I will increase my speed. Let me fire once again. And I'm going to note it down from here. Reset this. 5, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, wow, 17, 18, 18, 19, 19, 19, 20, 21, 20.4. Note it down. Let us fire it once again. $19, 20.41. Fire it once again. 20.4, 20.41. Say 20.4. $30, $40, $50. Do I have space for this? Okay. Now let us make this 30. 30. Fire this. You should expect a distance to be more than 20. Already gone to 45.1. 45.1. Let us fire it once again. I think it's better to increase a little bit of animation speed. Can I do that? No. Because I won't get the correct value, right? .45.8 I got. No. 45.1, 45.8. Once again. $45.9. Okay, let me write it down there. $45.1, $45.8, $45.91.